So the topic is Armstrong number. As we all know, Armstrong number is like 371. This is an example. So 3 raised to the power 3 plus 7 raised to the power 3 plus 1 raised to the power 3, which means all the digit raised to the power the total number of digits. For example, this is an Armstrong number. For example, if there is a number 161, it is not an Armstrong number, but just for the example, 1 raised to the power 4 plus 6 raised to the power 4 plus 1 raised to the power 4 plus 6 raised to the power. So add up, and if this will give 1616, then it's an Armstrong number, but sad, this is not an Armstrong number. So the logic here is, just a second. So the logic here is, we have to take a number. For example, we have taken this 371. And what we need to do, we need to slash the last digit and raise it to the power of total digit number. Like what we'll do, if 371, we'll slash this one, then we'll remove it, then we'll have 371 to 37. Then what we'll do, in 37 we'll again slash this 7 and we'll be left with 3. So we'll have the single digits left. Like how do we separate number 3 7, how do we separate 1? We'll slash this 1, we'll hold it here. In 37, how do you slash 7? We'll slash this 7 and then we'll be left with 3. So we'll be having these three numbers separate, 1, 7 and 3. These three digits will be separated and we can then raise them to the power 3. Why 3? Because there are 3 digits. So now how slashing is done. Slashing is done using a variable reminder. You can take any variable and whatever num we have, like here we have 371. Whatever num we have divided by 10. So if we divide 371 by 10, we'll receive 30717 and 1. We'll receive 1 as reminder, and this remainder can be treated as a single value in rem variable, and then we can raise this rem to the power 3. This is the same thing what we have done here in our code, rem divided by n modulus. First we'll take the modulus. This is modulus, like instead of dividing will give you this 37. Instead of this, whenever you will take modulus, like 37 modulus of 10, this will gives you the remainder, which is 1. And 371 divided by 10 will give you 37, because it will provide you this thing. Similarly, after 371, what we have done, in remainder we will have 371 modulus 10, which will give us 1. Now what we'll do, we'll store, we'll use this num as slicing this 371 divided by 10. Then what we'll have, we'll have 37. And in our variable digit, variable, what we'll do, we'll just use a power function. Use this power function using remainder is 1 and length is 3. Length we have calculated already, we have calculated the length of 371. Length of this is 3. So 1 raised to the power 3 is equals to 3. Now we'll go for another bit. rem equals to 37, because we have sliced this to the 37. Now number new value is 37. We'll 37 modulus 10. This will give us output as 7, and in num we'll have 37 divided by 10. This will give us 3. So now we have both our numbers 7 and 3 separated out. We have already calculated on the 1. Now what we'll do, now we'll take the digits 3 and 7 and we'll raise them to 3 raised to 3 and add 7 raised to 3, and we have already done with 1. So this will give us 377, which is basically a Armstrong number. So this whole program does the same thing, digit, num, rem, and this is running greater than 10. Num is greater than 10, which is 371 is greater than 10, because the logic here is, once you have sliced 371, it will give 37, and then you have sliced 37 by 10, it will give 3. So this 3 and this 37, this is greater than 10 obviously, but this is not greater than 10. So if this 3 goes in this loop and we will perform this modulus and division, this will burst our loop, this will burst our code. So basically the condition here is to prevent this after the slicing of 37 and after the slicing of this 37, this gives us 3. So 3 is less than 30 and 10.